Welcome to a video that will show how to determine the unit normal vector to a surface. If big f of x, y, z is equal to f of x, y minus z equals 0, and the gradient of big F doesn't equal the 0 vector, then the unit normal vector to f of x, y is defined by the gradient of f divided by its magnitude. So we need to normalize the gradient of big F. Now we do need to be a little bit careful about this. We've talked about the gradient of little f in terms of x and y, and we've also talked about the gradient of big F in terms of x, y, and z. Remember, the gradient of little f is going to be a vector in the xy plane, and the gradient of big F is going to be a vector in space. So we're talking about a vector in space when we determine the unit normal vector to a surface. Let's go and take a look at an example. Here we want to determine the unit normal vector to the given surface at the point 2, 1, 1. So let's first start by defining big F of x, y, z. That's going to be equal to x squared plus y squared plus z squared minus 6 equals 0. And then in order to determine the gradient of f, we're going to have to determine the partial derivatives with respects to x, y, and z. So the partial derivative with respects to x would be 2x. The partial derivative with respects to y would be 2y. And the partial derivative with respects to z would be 2z. Let's go ahead and evaluate these partial derivatives at the point 2, 1, 1. So the partial with respects to x when x is 2 would be 4. The partial with respects to y when y is 1 would be 2. And the partial derivative with respects to z when z is 1 would also be 2. So the unit normal vector at the point 2, 1 would be equal to the gradient of f, which is 4, 2, 2, divided by its magnitude. So we'd have the square root of 4 squared, that's 16, plus 2 squared, that's 4, plus 2 squared, that's 4. This is going to be the square root of 24, so we have 1 over 2 square root 6 times 4, 2, 2. Let's go ahead and multiply this. We're going to have 2 over square root 6, 1 over square root 6, and 1 over square root 6. Let's go and take a look at this unit normal vector in space. Here's our surface. The blue point is the point 2, 1, 1, and this red vector is our unit normal vector. Notice that it's also orthogonal to the tangent plane at that blue point. That's going to do it for this video. Thank you for watching.